All right, here I am in my kitchen, and I have a whiteboard, so talking about these limit problems, and I just want to talk for a second about this limit. This is the first limit that we found the derivative of, and we did that by expanding out this bad boy, this x plus h squared, getting something along the lines of, I'm going to write the limit every time. X squared plus 2xh minus plus h squared minus x squared h. It's already a lot. This is the easiest one. Those cross out an h from all this. Limit as h approaches 0. Oh, don't need that. Of 2x plus h, which just becomes 2x. Now, let me actually just go way back up. That means that this limit was really equal to dx. Oh, I do have more colors. Yes. X squared. Right? All that feels easy now. But there was that very long summer day where we were in Miss Carney's room and, did these for hours until we noticed the pattern. Now, if I ever put something like this in front of you, it's not a very big whiteboard. Let's say 4x cubed. Right, so the derivative with respect to x of 4x cubed. You would never sit there and do all this. Can you imagine that? If you've got a cubed, that means you have to expand it 3 times. It's a nightmare. Now you're a full-grown calculus. You're a full-grown calculus student. You are just going to give me the power rule and call it a day. Wonderful. Right, because why would we do that? Now, these limit problems do get infinitely more complicated, but let's take a look. Ultimately, whatever I put in that second spot is, that's what I'm trying to derive, right? So what if I put something, let's do sine of x plus h minus sine of x. Right, now again, I'm passing all my tests. I've got an h. I can see this bad boy right here. If I really wanted to, I really do want to. So I'm going to write that this is equal to the derivative of sine of x with respect to x of sine. Now, again, fully grown calculus, I know that that is equal to cosine of x. Now, there's a few different ways. There's one thing that I want to underline is just the writing. So this limit is equal to the derivative with respect to x of sine of x. I know that's one of our identities. The derivative of sine of x is cosine of x. So this limit is equal to this, the derivative of this is equal to cosine of x. Meow. What if I make things a little bit uglier? I've got the limit as h approaches 0. What's something terrible? Oh, I know. Yeah, we're really going to spice it up. Let's do 5 plus h minus natural log of 5h. Now, this is, you're going to say, Mr. Sunny, there's no numbers here. This is still a derivative problem. Just look, I've got this 5 and this 5. Those are what I'm calling the conspicuous numbers, right? The numbers that really stick out. So I'm just going to store that 5. I am going to rewrite this whole thing just for my convenience. So I'm going to say think the limit as h approaches 0 of natural log of x plus h minus natural log of x over h. And I'm just going to highlight those x's, right? Those x's replace those 5s. That's, again, the conspicuous number, the noticeable number, right? The number that looks like, what are you doing there? Anyways, Now this limit is equal to d natural log of x, right? The derivative of natural log of x with respect to x. Get that there. And again, I am a calculus student. I know all my identities. I know the derivative of natural log of x is 1 over x. So that doesn't really help, right? Because now I have to go back up here. But let me actually just get rid of my think. Back up. Oh, look, Taskmaster stickers. So how, after you've done your thinking space, and I'm working with fairly limited space, I'm going to set this limit equal to the derivative of natural log of x, not 5x, dx. But that's going to be evaluated, that's what that bar means, at x equals 5. So the derivative of the natural log of x is 1 over x. So this is really 1 over x evaluated at x equals 5, or just 1 over 5. Right, so there's a whole lot of notation, but the conspicuous number, and rewriting that limit once you've identified that conspicuous number is a challenge. Let me do one that's a little bit spicier, and then I'll call it a day, where the conspicuous number might not be quite as obvious. Let me take a leap back. All right. And again, writing more and thinking less is always going to be the way to go. So now let's do something like the limit as h approaches 0. Let's say 32 and 4, 2 plus h cubed. All that's 5 by h. All right, super gross. I'm going to go over here so it's a little bit more noticeable, right? Because I have 32. What the hell is that? But I do have this 4. So I am going to factor out a 4. Right, this will be I'm gonna actually, I'm not even gonna say factor out, because if you know factor out, you can probably figure out the rest. I'm gonna just divide everything by 4 and just sort of knock out a 4. So I'm gonna make this the limit as h approaches 0. So the 2 plus h cube doesn't change, but this becomes 8. And by golly, I know that I'm looking for something with 2 and cubed. So let me try this. Two plus h cubed minus 2 cubed, and conspicuous number alert. Right? This and this. And remember up here, I can almost draw those 4s back in, right? 4 times 8 and the 4 out there. Now everything here is equivalent. And I hope that it's obvious. My conspicuous number is 2, so I'm going to open up my think bubble. The limit as h approaches 0, x plus h cubed, 4, minus 4x cubed, h, equals d 4x cubed dx. Oh, I'm cooking with gas now. Equals 12x squared. Everything comes back to that puppy. All right, what does that mean? That means I'm just going to come back up here. My conspicuous number was 2, so that's what I'm going to evaluate my derivative at. So that's just going to mean that this up here, my original, is equal to d 4x cubed dx, evaluated at x equals 2. So again, 12x squared, evaluated at 2. 12 times 2 squared. I could leave it like that because this is AP Calc, but why not just finish for good form? 12 times 4, 48. Ooh, beautiful. But just to, again, highlight this process, let me just step back. Look at all that beautiful calculus. I started here. I said that 4 is annoying. Let me ignore it. So I divided each of those terms by a 4. And then my math sense alarmed when I had that 8 and 2 cubed, right? You gotta have some sort of like, what am I looking for? That cubed is gotta do something. Rewrote, saw that 2 is a conspicuous number, opened up my think bubble. Once I'm here, I'm doing the d 4x cubed dx. Oh, I know that's just a derivative, boom. And now when I just need to do the derivative and evaluate the value of the derivative at x equals 2. And now I get down here. Okie doke.